Are you overwhelmed by the vast variety of types of ML interviews? Do not worry. This is the only video that you need to watch for understanding the different types of interviews in detail. Along with different rounds, I will cover a variety of questions for each type of interview to help you understand better. Hi, my name is Umang and I have 4+ years of experience working in machine learning domain at Big Tech. I am currently a machine learning engineer at TikTok and previously was an applied scientist at Amazon. Like many of you, at one point I have been unclear about ML interviews and honestly overwhelmed by the vast scope of what can be asked. But I have been able to crack ML interviews at Big Tech at including Google, Atlassian, Amazon, ByteDance, TikTok, etc. Now I want to help you succeed in your ML career. First, let's understand an important fact. ML interviews vary a lot, and they are shaped by three main factors: company, team, and role. Unlike coding interviews or data science interviews, ML interviews don't follow a universal industry standard. Different companies approach ML interviews in different ways. This depends on their size, culture, and the kind of products they work on. Let's start with big tech companies like Google, Amazon, Microsoft, and Meta. These companies hire a lot of people, so their interviews are standardized. They're looking for candidates with strong ML and engineering skills who can work across various teams. Because these companies operate on a massive scale, they value people who can solve complex problems efficiently and create systems that are reliable and scalable. Now, startups. Startups are a different story. They usually look for candidates who can jump in and contribute right away. You'll need to be good at solving practical problems and handling multiple tasks. For example, you might have to work on data engineering, create a model, evaluate it, and even deploy it into production. Startups also focus on specific needs based on their product or niche, so being knowledgeable in their domain is more like a necessity. Finally, research-focused companies like OpenAI and DeepMind. These organizations care deeply about innovation and advancing the field of machine learning. They are looking for candidates with a strong understanding of ML theory and the ability to come up with new ideas. Now, instead of just applying existing tools, you will be expected to think creatively and even invent new algorithms. So depending on the type of company you're applying to, their expectations and the way they approach interviews can vary a lot. It's important to know what they're looking for so you can prepare effectively. Next, let's talk about the team. The team you're interviewing for really matters because it directly impacts the technical domain and the priorities of the interview. Even with a big tech company, different teams focus on different aspects of machine learning. Take Amazon for example. Even though it is the same company, the interview process can vary depending on which team you're applying to. For example, NLP teams, the ones working on Amazon Alexa, they are focused on natural language processing tasks. If you're interviewing for a team like this, expect questions on things like transformers, tokenization, and how to improve language models. You might be asked, how would you fine-tune a model like BERT for sentiment analysis in Alexa? Then we have computer vision teams. You could be working on projects related to Amazon's physical stores like Amazon Go. These teams focus on tasks like object detection and image recognition. So you might face questions on convolutional neural networks or real-time video analysis. They could ask a question like, how would you optimize a model to track products in a real-time store environment? Then we also have teams for recommendation systems. For instance, working on Prime Video within Amazon, they might focus on algorithms that power personalized recommendations. You could be asked, how would you improve the recommendation engine for Prime Video to better predict users' preferences? So as you saw, even within the same company, each team has its own specific goals and challenges. It's important to understand the team's focus so you can tailor your preparation and be ready for the right kind of technical questions. Let's cover the third factor here now, roles. ML roles fall primarily into two titles: machine learning engineer and applied scientist. These roles are very similar, but still different. That is why understanding the distinction will help you prepare more effectively. As a machine learning engineer, which is in short called MLE, the emphasis is on end-to-end problem solving. You are expected to handle the complete machine learning pipeline, that is, working on everything from problem understanding to deploying the machine learning solutions. For example, you might be asked a question like, how would you deploy a XYZ model to handle large-scale data in production? Here, the focus is both on ML concepts and technical aspects of building systems that work well in the real-world environments. And on the other hand, as an applied scientist, the focus shifts towards deeper model-focused problem solving. Now, just like in MLE, you do work on the real-world problems and work on the ML pipelines, but your main focus is on model building. A typical question could be, what modeling techniques can be applied to improve the coverage of XYZ model by 20%? Applied scientists need a deeper understanding of machine learning concepts in at least one domain like NLP, recommendations, LLMs, etc. So whether you're aiming for an MLE or applied scientist role, the difference lies in the scope of the work. MLEs focus on building and applying machine learning solutions in practical contexts, while applied scientists focus more on refining and improving the models themselves. Now, having learned this important context, let's now dive into all types of possible ML interview rounds that you can encounter. You won't be asked anything else apart from these 8 types. Now you will see the pre-recorded video from the Crack ML mentorship program. Remember that you won't be asked anything else apart from these 8 interview types in your machine learning interviews, especially at Big Tech.
Hi everyone, welcome to Crack ML's Chapter 2, and in this we will be discussing all the round types that we can encounter during our ML interviews. And we're starting off with DSA coding. This is nothing different from the typical coding interviews that you have, but the main 3 things that you need to remember in this is, first is pattern understanding. You can do 600 questions, 700 questions of the same topic even, and still fail these interviews because you haven't covered all the patterns. So you need to understand the patterns behind a lot of these questions and relate all these problems to those patterns so that it's easy for you to solve a new problem also, because there are only limited let's say 15-20 patterns and most of the problems are based on those patterns. So that is the first thing. Second is optimization. In these interviews, you can't just give the brute force answers. You need to have an optimal solution also. You need to discuss a lot of different solutions with the interviewer. And the third is speed. Given that ML interviews covers a lot of different things, so there can be a lot of scenarios where the coding interview can only be just a part of the entire interview. So you need to be very quick on your feet and solve them. And at max you will be having 1 to 2 coding interview rounds, and the questions can be asked a lot more, and you need to ensure that your speed is such that you're able to solve 2 medium hard questions within 1 hour or within 45 minutes. Now let's cover some of the main questions that we can see during the DSA interviews. The first kind of topic that we can encounter is arrays and strings, and this can include a lot of different patterns. For example, hashing, sliding window, array manipulation, sorting, hashing, dynamic programming, and there can be a lot of questions based on these. But here I have highlighted the top 6 questions that you can be asked from this particular topic. Next we have is linked list. Again, this is also a very crucial data structure. And for that, some patterns can be iteration, recursion, fast and slow pointers. So you need to remember these patterns, and based on this, you will be able to solve a lot more questions, and not just of this data structure, but also of different data structures. Again, linked list is very important. So next we have is trees. Trees is also another very crucial data structure, and for that there are a lot of patterns. Primary one is recursion. This is very important to do majority of tree questions, and you need to have a very solid understanding of the recursion pattern. Tree traversal is also very important, obviously stack, etc. So I did not summarize one more thing. So there can be a lot of questions which can include multiple patterns, not just one. So for example, in this validate binary search tree, it includes both kind of things, tree traversal and also recursion. So you need to be able to do so many questions so that you can use 1 pattern, 2 patterns, even 3 patterns in just one coding question. Then we have graphs. Obviously, this is another important data structure. This includes popular patterns like depth first search, breadth first search, and there's a lot of different questions that can be built in the graph section. Very important. Again, I've just listed the 2 most popular questions. Then we have dynamic programming. This might not be asked that much in, let's say, entry-level roles, but again, it is one of the key topics. You need to understand the concept behind it and do most of the popular questions for dynamic programming, like longest increasing subsequence, knapsack problem, edit distance, etc. Then we have backtracking. Backtracking is also again very important and has very popular questions like the n-queens problem, permutations of a string, etc. The last topic is basically miscellaneous, which covers other different patterns, for example heaps, sorting, hashing, etc. Top k frequent elements was a question that was asked to me in my interview. Again, very popular question. Find median from a data stream, very popular question. Again, I'm repeating that you need to be able to understand the patterns, understand those approaches, those strategies, and then apply them to all these questions that you practice. Next, we move on to ML breadth, and in this, focus is always on two areas. First is ML fundamentals, and the second is ML latest works. So you need to have a solid understanding for both of these areas, otherwise you might not be able to do well in this interview. And now we will go over some of the popular questions and topics under this interview. So the first topic is supervised learning. You will be asked very basic, very fundamental questions like the bias variance trade-off, precision recall, and like other evaluation metrics. How would you approach hyperparameter tuning? How do you handle data? How do you handle class imbalances? So a lot of like different questions can be asked in this area. So very crucial topic. Second is obviously unsupervised learning, differences between clustering algorithms like k-means, hierarchical clustering. Again, explain the concept of dimensionality reduction, concept of visualization, and ranking algorithms and other also fall into the unsupervised learning. Then we have model evaluation. What is cross-validation? Why it is important? How would you assess the performance of a regression model? So for evaluation, there can be metrics based on, let's say, a particular model, or there can be like some generic metrics. So you need to have a grasp understanding of both of these areas and at least know the general metrics that can be used across models and understand each of them deeply and all of their pros and cons, like which one should be used in which scenario. And the next topic is ensemble methods. This is also very crucial as it basically means like combining different architectures of models to produce like one final model. So there can be lots of like pros, cons, which one to use in which situation. And in this, I've highlighted only two most popular questions that are like explaining the different techniques of ensemble methods and their like advantages and like disadvantages, and like what is the difference between boosting and bagging. This is specific to tree algorithms, and when we combine a lot of like different trees, when we use boosting, what happens, when we use bagging, what happens, like pros and cons, which one to use in which scenario. So you need to have a solid understanding of all of these concepts. Next topic is deep learning, understanding like convolutional neural networks, understanding recurrent neural networks, understanding other different types of deep learning methods, understanding the latest works on LLMs. All these are part of like deep learning topic. The next is optimization techniques, regularization to avoid overfitting, underfitting, dropout techniques, what is gradient descent like, what are like different loss functions that we can use. So there can be a lot of like different pain points. There are a lot of like different ML components for which we can do the optimization. So we need to go step by step and like understand all the fundamentals behind each of these different components in terms of data set, in terms of features, in terms of models, in terms of evaluation, and understand how we can optimize each component to improve the overall model. Next is feature engineering. What is feature selection and why it is important? What kind of features do we need to select for different scenarios, and how do you handle missing data? This also depends on the field of the problem. So unless and until you see a lot of these examples, like learn about them, even practice a lot by your own, build some projects, either way you need to be able to have this knowledge when you're interviewing. The last is like the latest ML. Regarding LLMs, you need to know what are the state of the art models. How is Llama different from, let's say, OpenAI's GPT-4 model? In just like overview, not like going into the very details of it, but like understanding the main differences. For example, like Llama is open source, OpenAI's model is not open source, and like some other benefits and disadvantages, which one to use in like which situation. So you need to understand like some of these things, like overview of the transformer architecture, which is the backbone behind these LLMs. Just a lot of like the latest news of ML, for example, like Midjourney and other things also that you need to know before like giving this round. The next we go into is ML depth. This is like advanced knowledge for machine learning in at least 1 to 2 areas. You need to show that the projects that you have written in your resume, you need to have a solid understanding of those areas at least. For example, let's say in your one of the projects you used a tree model. The next direct question becomes, why did you use this tree model? Why did you not use, let's say, logistic regression or linear regression? Why did you not use a deep learning model? Why did you only use this particular tree model? And what were some of the optimization techniques you used in this particular tree model? Literally, one interview can go on just based on one of your projects. So unless and until you don't have a deep understanding of that area, of that particular component, of that entire field of ML, you won't succeed this interview. Here I've written like 20 examples that can be asked just from the tree algorithm perspective. For example, like how do they handle like categorical and continuous variables, trade-offs between using single tree versus ensemble of trees, significance of maximum depth parameter, feature selection from decision tree standpoint, role of hyperparameters of tuning the trees, and it can go on and on. Like It will touch all the different parts of the machine learning model cycle, from let's say dataset creation to tuning and like final deployment of these models, also evaluation, limitations, gradient boosting over random forest like scenarios, handle the missing values, common techniques for pruning the data, what is pruning can also be asked, then multi-classification problems versus binary classification, how the decision tree works in these scenarios, difference between bagging, boosting, underfitting versus overfitting for decision trees, how to use decision trees in the real-time applications, strategies of visualizing decision trees, feature engineering for improving the performance. And now we have like some of the questions regarding resume projects for ML Dev. Why you chose X evaluation metric over Y? Why you chose X model architecture over Y? What are the 3 things that you can do to improve the project further? What techniques did you use for data handling? Explain them. Why you chose X business metric over Y? How did you deploy this model? Explain the process. As I said before, you need to know ins and outs of everything you write into your resume. You need to know ins and outs of those topics in detail, at least 1 to 2 areas where you have that depth knowledge. For example, one can be trees, one can be other like classical ML models, and this is totally fine. If you haven't worked on deep learning, this is fine. A lot of like quant trading firms even still rely on a lot of like classical machine learning algorithms, literally. So there's no shortage. You just need to have good depth knowledge in 1 to 2 areas. Doesn't matter the area. If it is the latest area, it's a plus point, but it doesn't hurt you if you will not have expertise in those latest area. The next topic is ML coding. In this, there are 3 different types of things that can be asked. The first is ML algorithms, the typical ones. For example, you can be asked to build, let's say, logistic regression model from scratch. So you need to understand how you can code it from scratch in Python during the interview. So this basically tests your understanding of whether you know the fundamentals behind like these ML models, whether you understand the maths behind it, whether you understand the loss function behind it. You might be allowed to use, let's say, pandas library or numpy library, but you won't be able to use, let's say, PyTorch or something. You have to develop the logic of the model by yourself. The second is SQL problems. For a lot of like MLE applied scientist roles, you would be leveraging SQL a lot to query a lot of like Hive tables, query other kinds of like data tables, evaluate to analyze data sets that you will be using in your machine learning models. The last is math problems and understanding concepts like statistics, understanding concepts like probability, understanding concepts like some of the calculus. Is important for you to become a machine learning engineer and also an applied scientist, because a lot of these ML algorithms are based on these advanced maths like calculus. A lot of these experimentations that we do are based on like hypothesis testing and like other forms of statistics and probabilities, and the model scores that we produce are also probabilities. So we need to understand at least main math concepts and the coding questions related to those. Some examples of ML algorithms are write code to implement logistic regression from scratch, including the cost function, gradient descent optimization, create a decision tree algorithm, perform k-means clustering, perform k-nearest neighbors, design and implement a basic neural network using NumPy or PyTorch. Actually, this should be not PyTorch, it should be pandas to solve a classification problem. Given a data frame, implement methods for handling missing values and normalizing data to like pre-process the data. How would you clean the data? How would you handle the data? Doing the k-fold cross-validation to assess the performance of machine learning models. So you need to understand what it is, how it is implemented. This is the k-nearest neighbors. This is like ensemble methods for decision trees, gradient descent optimization. So you need to understand how the backprop works, then implement logistic regression, linear regression, and all those things. Some SQL problems, these are like the basic SQL problems. I'm not like reading any of these, but you need to understand the basic concepts like join, other basic concepts. So the next we have like some examples of math problems, and in this, if you can see this last question here, regarding randomly select k integers from the streams such that an integer has an equal probability of being selected. I failed an interview at for this. Initially, during giving the first loop, I was asked this question and I wasn't able to solve this math problem. This is literally a sampling technique called the reservoir sampling, and unless you know that, you won't be able to solve this optimally. You need to understand Bayes theorem, you need to understand eigenvalues, write a simple algorithm to minimize a quadratic function. This is basically like a loss function, mean, standard deviation. You should be able to like write code for all these basic math terms. The next type of round is ML design. This is also very important, like it will ask you to design an ML solution for a real world application. It's more like a discussion interview. You might have to draw some components. It can be a whiteboard session or it can be just a verbal discussion. And this design interview is focused on model. So model focus, like how would you train the model, what kind of features you would select to build this model, how would you evaluate the model performance. Some problems in this case can be across like multiple different topics: fraud detection, predictive maintenance, content recommendation, image analysis, customer insights, automated screening, sentiment analysis. In all of these scenarios, you would have to design a model to solve a particular like problem. All these are like real world problems in this case. Same here, design a voice recognition model, traffic prediction model, user churn, anomaly detection, forecasting model, virtual assistant model. And to be honest, it's okay. Let's say they ask you to design a forecasting model for the interview. And let's say you haven't worked on forecasting models in the past. So first of all, you can make it clear to the interviewer that, okay, yes, you do not know anything about the forecasting models, but you can approach it from whatever models you know. So you can either like make it clear initially, or you can basically ask them to like change the question itself. And the interview should be fine. They won't judge you on that because they understand that there's a lot of like different areas in machine learning. So they cannot like expect you to understand and know each of those areas in deep. As you can see here, the questions keep going on and on. They can be across like different areas, including the recipe suggestions, like a recommendation model for meal planning based on preferences. In some scenarios, you will have like very limited data. In some scenarios, you would have a lot of data. So for example, in these scenarios for personalized education, for personalized meal preferences, so you might have like limited data. In some scenarios, you can have a lot of data. For example, automated content moderation model for online platforms. In this case, social media can have a lot of data. So these problems cater a lot of like different areas of real world problems. The next is like ML system design, designing an end-to-end machine learning solution for a real world application. Here we're talking not just about the model specific things, feature selection, model development, data ingestion, and all those things. We are also talking here about which API is being called, how is the model being served, how is the training being done, what databases are being used, all the technologies behind it. So you would be discussing all of these different areas, all of these things during this interview. And this is usually not expected for internship or entry level. It's more for like mid-level or senior level roles. So the only difference between these questions that you would see from ML design here all of these things were based on a specific model. And here everything would be system. That is it. Everything else remains literally the same, but the expectations increase because you are expected to know a lot more about end-to-end machine learning solution here. This particular interview might also not ask for applied scientist role because they focus more on like depth, they focus more on ML design. They are not concerned a lot from the systems standpoint, but for MLE roles, it is very important for mid to senior level roles. The next is the very typical one, the behavior round. It can also be of two types. One can be a general round, general types of behavior questions that are asked in almost like any kind of like job interviews, and the other is like ML focused behavior questions. So for ML focus, I can like give you some examples here. Describe a time when you had to choose between different machine learning algorithms, which factors led to your decision. Basically, it's like more from your resume focused questions. You can build up some scenarios in your head already and have these answers ready. When your model did not perform as expected, what did you do in that scenario? Tell me about a time when you had to work with messy or incomplete data. What steps did you take to complete it? So how would you explain this concept to a non-technical stakeholder? So when you had to collaborate with cross-functional teams on an ML project, explain the scenario, what challenges did you face, and so on and so forth. So a lot of like different questions can be asked. I'm not going through all of them, but you can like at least do these questions that I'm being going through all of these slides in all of these different round types. At least do all of this for ML preparation. For general, I'm not going to go into the details, but you can see these questions here. Next is combination. So in reality, most of the ML engineer or like applied scientist interviews that you will have will not be just solely based on, let's say, ML breadth, solely based based on DSA coding, solely based on ML depth. They will usually be a combination. So first example can be DSA plus ML coding plus behavior, ML breadth plus ML depth, ML coding plus ML depth, ML coding plus ML design. So it can go on and on. The combinations can go on and on. You cannot like expect the interviewer to only ask you one type of questions. It all depends on the interviewer, all depends on its mood also, and all depends on the team's requirement also on the company's requirement. So prepare everything in advance and be ready for any kind of interview. If they are expecting you to discuss ML breadth for 2 interviews, be ready for that. If they're going to discuss ML depth for 2 long interviews, be ready for at least 2 areas for ML depth.
Alright, how did you like this breakdown? Drop a comment and let me know. You might feel like it was a lot to digest. And yes, it is a lot. But this is what it takes to be a machine learning engineer. And if you have more questions, feel free to directly email me. I wish you the best and I'll see you in the next video. Peace out.